Hello everyone, welcome to my channel. Today in this video I will be proving a theorem which states that union of two subgroup is a subgroup of G if and only if one subgroup is contained in other. So we will be proving this theorem. So first we will be proceeding. We will have to prove this theorem in both directions. First we'll consider two subgroups. Let H1 and H2 are two subgroups of the group G. Now let's consider that one subgroup is contained in other. It means either H2 will contain H1 or H2 will be contained in H1. So in both the cases we have either H1 union H2, it will be equal to H1 or H2, or H1 union H2 is equal to H1. So let's see the condition again. So if H1 is contained in H2, then H1 union H2 will be equal to H2, which we know that H2 is itself a subgroup of G. So this condition is satisfied. Secondly, we have taken OR condition. If H2 is contained in H1, then H1 union H2 will be the bigger set, which is H1. H1 is also a subgroup. Therefore, H1 union H2 is also a subgroup. Now we'll be checking the reverse condition. Conversely, we have to for this we have to prove. Let's prove this in this way. Let H1 and H2 be two subgroups of a group G. So we'll take the reverse condition of the first part as of the first part. Let's suppose H1 is not contained in H2 and H2 is not contained in H1. It means that A belongs to H1. Since H1 is not contained in H2, therefore implies A does not belongs to H2. Similarly, if we take B belongs to H2, B will not belongs to H1. Now let us suppose that A comma B belongs to H1 union H2. Which will imply that we have taken here normal addition in this group. So we'll be taking that A plus B belongs to H1 union H2. So A plus B will belongs to H1, or A plus B will belongs to H2. Now since A belongs to H1, A inverse will also belongs to H1, which means A plus B inverse of A in this case will be minus A. Here, or in this case, inverse of B will be minus B. A belongs to H2. Since we have taken A belongs to H1, implies A doesn't belongs to H2. And in this case, we have got A belongs to H2. And in this case, we have taken B belongs to H2, implies B does not belongs to H1. And in this case, we got B belongs to H1. But B does not belongs to H1 and A does not belongs to H2. Therefore, we have proven this statement. We can write the statement itself now. We can write it as subgroup if one of them contains the other. Thank you.